Complex numbers. Now, everybody should be fairly comfortable with the square root of -1 being I, right? That's honestly what the majority of this comes down to. The other key thing is what happens when you square I?
Equals -1.
Equals -1.
There was a song about it in advanced algebra.
I'm sorry.
It was pretty bad.
Now, we're going to look at more what the concept is, that complex number. The complex number has two parts, the real and the imagined. Okay, so it's always that a plus bi format, and that's the way your answers are usually going to look, is that a plus bi, and it needs to be written out that way. Okay, you can have pure real numbers and pure imaginary numbers, things like that, where a or b is 0. If a and b are both 0, you just get, well, 0. So if I want to write something like this in standard form, all I need to do is change the values so I don't have the square root of a negative number. I need to have an imaginary component. In this case, what would it look like in complex form? Yeah, what would happen to the square root of 9? 3i. The idea is, because I can split this up into the square root of 9 and the square root of -1, what's the square root of 9? Square root of -1? So, -5 plus 3i. Usually that's going to be the easiest way to do it, is just split up the square root so the negative is separate from the rest of it. Okay? Excuse me. Now, the nice thing about this is it's always going to be consistent. When you have complex numbers, as long as their real components are equal and their imaginary components are equal, then the complex version is equal as well. Okay? So, because of that, almost all of our regular operations work. If I want to add or subtract them, all I do is add the real components, add the complex components, and combine it together. Subtraction, same thing. Make sure, though, that negative sign is going to distribute to everything that is that second complex number. Okay? And all these formulas, if you like them, they're in the book. If I have a negative out front, I need to make sure I distribute that so that it attaches to everything. And just like with addition, you have 4 and -4, they're additive inverse. With complex numbers addition, you also have a plus bi and -a minus bi. If you add those up, they negate each other entirely. They're inverses of each other. So if I have something like this, I want to add together these two numbers. And these are just considered to be two numbers. What's the real component going to be? 12. What is the imagined component going to be? -i. So the addition ends up very simple. What's the real component going to be on this one? -2. The imagined? 6i. Yep. For this one, you have multiple parts here, but the rules still apply. What's the real component going to be? 5. The imagined? -7i. Because you have -5i, -5i minus 6i is -11i, plus 4i, -7. For this one, the real component would be what?
0? Would you put 0 or would
You
you
would
not?
put 0 for now, yeah, because we'll look at it. Because 5 and 3 is 8, minus 8, 0. What about the imagined? Yeah, 0i as well. -i plus -3i is -4i plus 4i, 0i. And yes, that would just be 0. Yeah, not bad at all. Okay. Now, like I said before, most of your operations work. Your distributive property, commutative, associative, all that multiplication and addition properties do work for this stuff. Okay? So, if I have this first one here. Now, one thing. First step on any of these where you start dealing with multiplication or division even, treat it like x to start. Treat it like a variable. Once you get everything cleaned up, all like terms combined, then deal with any i's you have left floating around. Okay? So on this one, what would I do first? Distribute the 8i. That's going to give me what? 32i, 24i squared. Now, anything that's bigger than just I need to convert. What is I squared equal to? -1. So, I'm going to rewrite this as 32i minus 24 times negative 1. And honestly, most people skip this step. What's going to be the real component in my final solution? 24 and the imagined plus 32i. That would be your solution. Okay? What about for the next one? What do I have to do there? FOIL. When I FOIL this out, I get 15. What do I get for the middle term? What do you get? 7i, yep. Because you have negative 5 plus 12 gives you 7i minus 4i squared. The I squared, again, is going to do what? Negative. Honestly, when I have something like this, what I'll usually just do, I'll change that to positive and cross that out. Because that's what's happening. It's minus a negative. It just doesn't look like it immediately. So then real component, I get what? 19, and the imagined is plus 7i. What about for C? What are those two things to each other? Conjugate. They act like the square roots up there. The idea being, if I multiply these out, I'm going to get 4, but what's going to happen to the middle terms? They cancel. So you have 4 and then minus 16i squared, but minus an i squared becomes plus, so you get 20. And then for these, inevitably I will have students that write this as 25 plus 9i squared. But you have to do what? FOIL. So I do get 25. I do get plus 9i squared, but what's in between there? Negative what? 30i. Negative 15 minus 15 is negative 30. Then what? Yeah, this 9, this I squared becomes negative. So what's the real component? Minus 30i. Conjugates, we already dealt with one of them. If I want to multiply this number by its conjugate, what's its conjugate going to be? 3 minus I. So when I multiply those out, the O and the I part of FOIL won't happen. So what do I end up with? I squared, which will turn into 9 plus 1, or 10. Conjugate for this one? 5 plus 4i. So I'm going to get 25, and then what? And honestly, even though you get comfortable with it after a while, it feels like you can skip this step, I still don't, because it's real easy to mentally skip that negative sign and then have the wrong sign there between them. Okay? So if you try to jump all the way to the end, I usually try to avoid it. That's going to turn into plus, though. You end up with what? 41. Easy?
Yep.
Okay. Quotient. Here's where you got to actually start thinking a little bit. Write the quotient in standard form. 2 plus I over 2 minus I. The problem is, I need to have that A plus BI format. Okay? So I can't have an I in the denominator of a fraction. So how do I get rid of it? Of the bottom. Yep. The idea is you want to multiply the bottom times its conjugate. But if you multiply the bottom of a fraction, you also have to multiply top. So on the bottom, you're just going to get 4 minus I squared. On the top, you're going to get what? Plus I squared. So on the bottom, that's just going to give you what? 5 on top. What's the real component going to be? 3, because that's negative 1, right? Plus 4i. And then I'm going to split up the fraction. So I have 3/5 plus 4/5 I. Okay. Excuse me. Questions so far? Yeah.
Are there
understood why the 3 that over 5 is worse than 3 fifths plus 4 fifths I.
It's not a matter of being worse. It's just basically a matter of being able to separate it out into both real and imagined parts.
Okay.
So, I mean, personally, I like this way better because you're writing less. I'm lazy, so writing less, good thing. But this consistent manner allows for, if you can guarantee it's in this kind of format, it allows for easier programming and things like that, where you need to be able to draw out of certain fields.
Yeah.
So that's one of the primary reasons, is because if you can see that formatting, you can tell something to draw out the first component and draw out the second component. Whereas this is trying to put it all together into one. I mean, that's honestly the main reason where it comes up nowadays. And it's just trying to be consistent. Okay. Let's see. Now, one thing that can get a little screwy is when you have something like this. Excuse me. If I want to write this complex number in standard form, the problem is when I have 2 square roots, your first instinct is, okay, multiply together what's underneath. The problem is when you do that, you negate the negative signs, right? But the original ones, I know this isn't going to have a very clean solution because you have those negative signs. I can't normally do the square root of negatives. So what I need to do first is pull any I values out. Okay, now the nice thing here is both of them have an I value, so all I end up with is I root 14 times I root 2. Well, what's I times I going to give me? I squared. What's the square root of 14 times the square root of 2 going to give me? Square root of 28. You just multiply together what's under the radicals. So, what's I squared though? Negative 1. What's the square root of 28? Because I can simplify that. Because what perfect square can I divide 28 by? Yeah, it's going to turn into 2 squared root of 7 because I can separate this out into 4 times 7. And the square root of 4 does give you that 2, so I end up with negative 2 root 7. Okay, and that's going to be consistent for those. Pull out the I values first, and if you ever have a number that you can simplify into the radical, you do need to simplify it. Otherwise, I will count it wrong. So what would I want to do first with these? Pull out the I value. So I have I squared root of 27 minus I squared root of 12. And what can I do with the 27 and the 12? What? Simplify, yes. How? What perfect square can I divide 27 by? 9. So you get 3 square root of 3. Because it's the square root of 9 times the square root of 3. Minus I times, what can you take out of the 12? So it'll turn into 2 square root of 3. Now, because the square root of 3's are both the same, now they're considered like terms. If I add those up or subtract them, what do I get? Yeah, you just get 1 root 3, or just square root of 3, times I. Okay, lastly, now, before I even bother squaring this, I want to just get the negative out of the way now. So I still have negative 2 plus, but what's this going to turn into? Yeah, I root 5. So then when I square it, what do I get? 4. This looks a little strange, but you're going to get negative 2I root 5 minus another 2I root 5. Yes, that'll give you the 4. So 4 minus 4I root 5. Then lastly, I have what? Yeah, 5I squared. And I squared is negative 5 is what it'll turn into, because that's negative 1 times 5. So I end up with what? Negative 1. That 4I squared of 5. Okay. A couple more. Quadratic formula. Find the complex solution to these. Okay? Now, that means I need to set up the quadratic formula. So this is going to be x equals what? Negative what in this case? Negative 14.
Plus or minus square root of 14 squared minus 4 times 80 times 5. All over 2 times 80.
Okay? Then go ahead and simplify it. You have negative 14 plus or minus. 14 squared is? You should know that one. 196. Honestly, squared you should probably know through 20. 4 times 8 times 9. 8 times 9 is 72. 72 times 2 is 144. 144 times 2 is 288. Over 16. 196 minus 288.
Negative number.
It's 4 to 200, then 88 more. 92.
I'm just starting out.
Okay. Over 16. Now, go for the simplification. Negative 14 over 16 will simplify. Plus or minus. I'm going to split this out. You have square root of negative 1. What perfect square can I take out of 92? Well, what's an easy perfect square I can take out? 4. What's 92 divided by 4? What's 100 divided by 4? 25. This is 8 less, so 23. Okay? So then, negative 14 over 16 is negative 8 plus or minus. That'll turn into an I at the end. Square root of 4 is 2. And what's 2 over 16? 1/8. So I just end up with square root of 23 over 8i. The square root of 4 gives you the 2. The 2 and the 16 simplify down to 1/8. Okay. For this one, go ahead and do this one. Without your calculators. None of these numbers are bad.
Well, I mean,
I don't
seven kills
think
someone.
mental math is not like.
They didn't kill them, it just ate them. They may have already been dead for all you
I feel like
know.
that's still murder, though.
Well, it might have been dead. I mean, 9 had already been dead. Eating a corpse is murder.
I still don't think you can do that.
What are you talking about?
We're talking about the number. You called 7 a murder. 7, 8, 9? Old joke.
Actually, seven's a cannibal.
Yeah, seven.
Yeah. Let's get real here.
Yeah, you can make that argument.
Did you lose it already? I'm just taking